Hey guys, welcome to Math Failure channel. In this video, we are going to learn how to add and subtract rational numbers that are fractions, and also as well how to simplify rational numbers. Well, if you remember, in the previous videos, there was a video I made about numbers. We talk about rational numbers. So we define rational numbers as numbers that can be written in the form of A over B. So as we see on the board, we have fractions here. For example, 12 over 3, 8 over, 4. We have 15 over 3. We have 4 over 2. So these are also fractions. Or in other words, we call fractions rational numbers. Before we go ahead and start solving questions, there are a few things I would like you to know because these are some of the critical points when come to dealing with fractions. The first point is that rational expressions can be simplified only under the multiplication property. Well, this is what I mean. In a case where we have A multiplied by B divided by B, for example, or should I write this in red? I think that would be better. A multiplied by B over B. Well, this is a multiplication property, okay? So under this case, we can go ahead and say, okay, we can simplify. This is what we call simplification. There is B here above and then B in the denominator. So we can go ahead and cancel the B's. B goes into itself one times, B into itself one times. So A multiplied by 1 is A divided by 1 is A. So therefore here the answer is A. So this is the first point I want you to pay attention to. I repeat, rational expressions can be simplified only under the multiplication property. And then the second thing to note is that rational expressions cannot be simplified under addition or subtraction property. This is what I mean. When you say A plus, or this can be minus, like addition or subtraction, some B here, and then we divide it by B. Well, this is a common mistake many students make. They will go ahead, cancel B with B and say the answer is A. Many students make this mistake when come to tests or in their exams. So I want to note it down here so that you also don't fall for the same mistake, okay? Well, this expression here, this is not equal to, okay? It's not equal to A, all right? That is, we cannot cancel this B and say the answer is A because this is under the addition and then subtraction property. We cannot simplify them. But when it comes to the case of multiplication, as in our first case here, we can go ahead and simplify them. So pay attention to this, especially this. This is a mistake many students make. When you have a number, like for example, let's say A is a number and then B also is a number, and then they are being added together or subtracted, like by a negative sign or a positive sign, okay? And then divided by some number again, you cannot go ahead and cancel them and simplify them, okay? So pay attention to this. This is not equals to A. So therefore this and this are different. When we have multiplication, we can go ahead and simplify. But on the addition and then subtraction property, we cannot simplify them. Now that being said, let's go ahead and solve these questions that we have on the board. In our first question, it says that 12 divided by or over, I like to call it that, 12 over 3 plus 8 over 4. Well, this is what I want to say. Each of these questions, I'm going to solve them in two different methods, okay? So that you can know also the other methods are also possible. So I'm going to show you the rational method and also show you the alternate method of solving this type of questions. Let's go ahead. Now we have 12 over 3. Well, if I want to solve this using fractions or rationals, the first thing we have to think about is LCM. Okay? We have what we call LCM. That is the lowest common multiple. Okay? L stands for lowest, C common, and M multiple. So what do we mean by the lowest common multiple? Let me show you here. So the lowest common multiple is a number, okay? The lowest, that is the smallest number, a smallest number in which the denominators can go into without any remainder, okay? So it's simply the smallest number in which you can divide the denominators, okay? So in our case here, the denominators are 3 and 4. Then what are the numbers that 3 can go into and 4 can go into? I think let us list them down and see. Let's say, okay, there is 12, 24 is possible. I mean, 4 can go into 24, 3 can go into 24, okay? There are even, we have 48. We have a lot of numbers, there are many. These are just a few things. I want to show you something. Now, which of these should we use to solve this question? Well, there's nothing like it is compulsory that you must use the lowest number, okay? It's not compulsory. There's nothing like a must. Now, if you go ahead and use 12 to solve this question, you will arrive at the right answer. The same thing applies to 24. The same thing applies to 48. But to make your work easier, to make your operation easier, especially if you are not allowed to use calculators or you are not using a calculator, it is always better to use the smallest number. Okay? So that's why people prefer using the LCM, the lowest common multiple. Now from here, you can see that the lowest is what? 12. So we are going to choose 12 as our lowest common multiple. So I will write 12 here down. So the next thing I'm going to do is to divide this to, I said 12 divided by 3. 12 divided by 3 is 4, right? Then what I'm going to do is, I'm going to take that 4 and multiply it by the numerator here, okay? So you use this one to divide. So if you divide it here, the answer is 4. Then you take this 4 and then multiply it by 12. All right? So let's go ahead and do that. 3 into 12 is 4 times. So we say 4 times 12. Let's say 12 times 4 plus. Here, the next thing you can do is 4 divided by 12. Okay? 4 into 12 is 3 times. Then we multiply 3 by the numerator. Okay? That is 8 multiplied by 3. Well, now here comes a place where you can use simplification. By the way, I could have used simplification from the very beginning. As I said, that's why I said I will use different approaches to solve the question so that you can be aware of them, okay? Now, if you look at this, we have 12 multiplied by 4, okay? And then here, we do have 8 multiplied by 3. If you go ahead, we multiply this, it's going to 12 multiplied by 4 is 48, okay? Then 48 plus 8 multiplied by 3 is 24. Then we divide this by 12. Now remember what I said here, because this is what I want to show you. We said you cannot go ahead and cancel B and say the answer is A, right? So the same thing here, like you cannot go and then even say, let me cancel out 12 and then 12 goes here 2 times. No. because the operation here is addition, not multiplication. If this was multiplication, we can go ahead and then cancel 12 1 into 24 two times and pass. Okay. So here's what you can do. If you know how to factorize, you can factorize and divide. Okay. But if you don't know how to factorize, let's just go ahead and add this, because I think everyone can do addition. So 48 plus 24. Let me show you how to do that here. But if you have your own calculator, like with you can just punch it 48 plus 24, that is 72. Okay? But in case you don't know, you can also say 48 here, 24, then 4 plus 8. 4 plus 8 will give you 12. You can write a 2 here and then carry the 1 here. Then 2 plus 4 will give you 6. 6 plus 1 is 7. So that will give you 72. Okay? Let's go ahead and say this is 72 divided by 12. Well, 72 divided by 12, this is 6. Okay? But for those of you who don't know, I'm going to show you how to solve this. Well, you can start from maybe a smaller number if you want. You can break it down because we talk about simplification of numbers. Think of a number that can go into 12 and also can go into 72. Well, there are many numbers, okay? Because, 2 can go, 3 can go, even 4 can go, okay? 6 can go, etc. But for the sake of this video, let's go ahead and use 6, okay? That will make our operation faster. But any of them can work. You can start from 2, simplify, easier if you want. Or let me even show you that method here. Okay, let's go. Let's start with 2. 2 goes into 12 6 times. Okay? 2 goes into 72. Well, 2 into 7 is what? 2 into 7 is 3 times. Okay? Then there will be a remainder of 1. You put that 1 here, then it makes 12. Okay? Together? If you put the 1 here, now you have a 12. Then 2 into 12 is 6. So we have 36 over there. Then below we have a 6. Can 6 go into 36? Of course. 6 goes into itself. Sorry, let me use a different color for that. 6 goes into itself 1 times. 6 goes into 36 6 times. So you have 6 over 1, which is the same as, because 6 divided by 1 is just 6. So therefore, the answer to this question is just 6. Well, let's say you don't want to go through all this, okay? To make it easier, I want to show you by just using simplification from the very beginning. We could have solved this question very easily, okay? Let's go ahead and do that. Well, we have 12 here, we have 8. Now what I want to let you know is that we can go ahead and just divide this, and then divide this. We are going to end up with 2 whole numbers in a form of a plus b, for example. And then just find the answer directly as 6, okay? Because 3 into itself is 1 times, 3 into 12 is 4 times, okay? And then 4 into itself is 1 times, 4 into 8 is 2 times. So you are remaining with 4 over 1 plus 2 over 1. And then 4 divided by 1 is just 4, plus 2 divided by 1 is just 2. So 4 plus 2 is just 6, okay? But for the sake of this video, because I talk about this, I want to make emphasis on this. We said that when we are dealing with rational numbers, if the two numbers have been multiplied, when there is a multiplication property, we can go ahead and cancel the terms. So that's what I want to show you here. Now we can break down 12 into 3 multiplied by 4, right? 4 times 3 is 12. So instead of 12, we are writing 4 multiplied by 3. Then we divide this by 3. Plus, now instead of 8, we can write 2 times 4, because 2 times 4 is 8 divided by 4. Now we have this kind of format where we have a multiplied by b divided by b here. Then you can go ahead and cancel the b's because they are the same. And then the answer is a. That's what I want to demonstrate here. So let's go ahead and see. Well, if you try to compare these two expressions. So it's like this is our A, this is our B, and this is our B. Remember we said you can go ahead and cancel these two terms, right? So that is 3 goes into itself is just 1 times, 3 goes into itself is just 1 times. You can cancel them, okay? The same thing goes to this 2, 4 goes into itself 1 times, 4 goes into itself 1 times. So what we have remaining is like 4 multiplied by 1 is 4 divided by 1 plus 2 multiplied by 1 is 2 divided by 1, okay? So we have 2 over 1. Well, 4 divided by 1 is just 4 plus 2 divided by 1 is just 2. 4 plus 2 is 6. So you see how easily we found the answer? And by the way, from the very beginning, as I said before, we could just have gone and say 3 goes into itself 1 times, 3 goes into 12 4 times, 4 goes into itself 1 times, 4 goes into 8 2 times, then 4 plus 8 is just 6 directly, okay? But for the sake of understanding the topic, because in your exams, your teachers will expect you to show the steps as I did. So that's why I'm showing you these steps, not the shortcut. But this is the shortcut. You can do a shortcut and then get the answer, very easily. Yeah. So let's go ahead and solve this question too. Then we will look into some harder type of questions because these ones are very easy. Well, as I said again, I'm just going to go directly and then use this method because before I show you the approach you can use by using the LCM method to solve the question, which is a longer method of solving rational expressions. But of course, at times you have no other option but to use the LCM method, okay? And from here, we can break down 15 into 5 times 3. 5 times 3 is 15 divided by 3 minus. We can break down 4 into 2 multiplied by 2 divided by 2. Okay? Again, we have the same format, okay, as this, A multiplied by B over B. The same thing here, the same format. So let's go ahead. 3 cancels 3, okay? 2 cancels 2. There goes into 1, 1, 1, 1. So there's no need for us to write it. Of course, if you want, you can write it, but it will not change the result because when you multiply by 1 or divide by 1, it's still the same, It doesn't make any difference. So we have 5 remaining here, minus, and then for here we have 2 remaining, minus 2. 5 minus 2 is 3. And this is the final answer to this question. I think these two examples are clear. Let's go ahead and then solve a bit harder questions that are harder a bit. And do not worry, by the end of this video, you will not have any problems with rational numbers, with adding and then subtracting fractions or simplification of fractions. We are going to solve a lot of examples, okay? Let me clear the code, okay? And then here too. Yes. Okay, what about when we have 48 divided by 4 plus 21 divided by 3 minus 10 divided by 5? Now this is what I want you to do. Pause this video, try to solve this question by yourself. Then you can unpause and then continue watching to see the solution. I hope you are done. Let's continue. Well, for this question again, as I said, we are going to use a similar approach to this because each of these numbers here that are the numerators can be broken down into smaller numbers. Let's go ahead and do that. And for those of you who will not be able to know exactly what numbers do I break this into, because for example, if you said 48, there are many numbers that you can multiply to give you 48, okay? You can multiply 24 by 2 to give you 48. You can multiply how do you call it, 12 also by 4 to give you 48. So which one are we going to use? how should we break this into? Because we can break it into different numbers, Well, that will depend on the denominator we have. Denominator we have here is 4. So we are going to think of, okay, 4 multiplied by which number is equal to 48, okay? That is the shortcut to do. Because if not, you'll continue, multiply, like you'll say maybe 8 times 6 is also 48, something like that. And it will make your work harder. So always look at the denominator. Then think that way. You say, okay, this denominator is 4. 4 multiplied by which number is going to give me 48, okay? So as I said before, 12 multiplied by 4 is 48. So over 4 plus, for 21 is 7 multiplied by 3, okay? Our denominator is 3. So which two numbers do we multiply together? Like, to be more specific, 3, that is our denominator, multiplied by which number will give us number 21 is 7. So we say 7 multiplied by 3. Again, we have a subtraction minus. For 10 also, we have 5 in the denominator. 5 multiplied by which number will give us 10? That is 2. So 2 multiplied by 5 over 5. Again, let's go ahead and cancel out because we have a multiplication property. Okay? As I say here, when we have a multiplication property, we can go ahead and cancel them out. It's not a problem. But whenever we have addition here, or we have subtraction, let me use a different color to do this so that it can be visible. Okay. Whenever we have addition or subtraction, we cannot use the simplification approach. Okay. Now let's go ahead. 4 cancels 4, 3 cancels 3, 5 cancels 5. And now we are remaining with 12 here plus 7 there minus 2. Okay. Here's the 12. We bring the plus sign, 7 here, the minus sign here, and then 2. Well, from here, now, as I said before, there's a video I made about the order of operations using PEMDAS. That is, whenever you have operation between numbers, and then it includes by different signs like a positive sign, negative sign, multiplication, by division sign. So use PEMDAS. Or at times it can also involve even parentheses, parentheses or maybe exponentials. Yeah. So we use PEMDAS to go by it, to do the order of operation. Otherwise, the results will be wrong. But for this case, I also explained in that video that if the only signs you have, the operation is only plus and minus, there is no need to follow PEMDAS, okay? Because it does not matter whether you start with the addition or the subtraction. For this kind of questions, you will still get the answer correct, okay? But if you want to use PEMDAS, okay, you can also go ahead. You say, okay, let me do the addition before the subtraction, but it will not make any difference. Okay, then 12 plus 7 is 19. Okay, 12 plus 17, 12 plus 7 is 19. I have 19 here. Then we bring down the minus 2. 19 minus 2 is 17. And this is the final answer to this question. Okay, as I mentioned, if you start with this, if you said 7 minus 2 is going to give you 5. So 5 plus 12 will give you 17. So you still have the same answer. Well, let's try a harder question. Like maybe, yeah, let's go ahead and try maybe some mixed fractions, maybe. Yeah, I think that would be a good idea. Let's just solve this. Let's say we get maybe 6 multiplied by 4 divided by 12. Okay. And then we have maybe plus 4. Okay. Then we have 10 over 8. Okay. Sorry, by the way, this is the multiplication. This is 6 here. Well, how do we solve this type of questions? Now, for those of you who don't know, I would like to give some brief notes here. Like whenever we have the form like A You have A, then you have B divided by C, you know, like here, in our case here. This is called mixed fraction. For those of you who don't know, when you say proper fraction is a case where if you said A over B, case, sorry, if you have A divided by B, A over B is a proper fraction whenever the numerator is smaller than the denominator, okay? So this is only a proper fraction, okay? It's a proper fraction when A is less than B. We call this a proper fraction, okay? But if you have a case whereby this A over B is a case whereby B is less than A, or you can say A is bigger than B, okay? So if the numerator is bigger than denominator, this is called a proper fraction. Sorry, this is proper fraction, okay? And this is improper fraction, okay? Whenever you have this case whereby the numerator is bigger than denominator, this is improper fraction, improper fraction, okay? Like in our examples that we solved so far, we were dealing with this type of fractions that are improper, you see, because the denominators are always, the numerators are always bigger, you see. 48 is bigger than 8, 21 is bigger than 3, and 10 is bigger than 5. So in all the examples we solved so far, they are improper fractions. But for example, here, if you look at, for example, this 4 over 12, 4 is less than 12. So this is a proper fraction because the numerator is smaller than the denominator, for example. Yes. So I just wanted to note this down here for those of you who don't know about the difference between proper fractions and then improper fractions. Well, let's go ahead with this. So I said whenever you have this is the same as A plus B over C, okay? When you have a mixed fraction, these are called mixed fractions, by the way. Mixed fraction, okay? Mixed fraction. So you can write this in the form of A, that is A plus B over C. These are equal. Well, now the question is, if you have a mixed fraction, how do you convert a mixed fraction into improper fractions? By the way, if you convert mixed fraction, like it is a mixed fraction, so if you write it in the form of A over B, it is always improper fraction because the numerator is always bigger than denominator. So how do we do that? Well, it is simple. You just multiply C by A. C multiplied by A. This is just a multiplication sign here. Okay? You multiply these two and then add the result to this, to the numerator. Okay? So this is how to convert mixed fractions into improper fractions. Now, that being said, let's go ahead and solve the question on the board. Okay? Now I have to clear these notes here. All right. Let's continue with our example. Again, as I said, we can always break down this into, maybe I should not have deleted this, but anyways, C, this is the same as A plus B over C. Just as a note here, maybe a side note here. Okay, this is the same as 6 plus 4 over 12. All right, then plus, again, this mixed fraction here is the same as 10, sorry, I forgot the 4. 4 plus 10 over 8. So this here is the same as this, is the same expression, okay? It has the same meaning. And this 4 whole number, 10 over 8, is also the same as this. All right? And by the way, uh, this is not a typical mixed fraction, because when I talk about typical mixed fraction, for example, I think I have to change maybe this. Maybe this should be something smaller. Okay, that will make more sense. Let me make this maybe a 2. Yeah, let this be 2. Okay, instead of 10. So that will result into a proper fraction. Okay, 2, for example. Now we understand this are what? The same things. So we have to simplify again. Okay, now simplification will take place here. I explained uh, in the example that I give, the property that you could just multiply this 12 multiplied by 6, and then 6 multiplied by plus 4, like 12 multiplied by 6, which will give you 72, then plus by 4, which will give you 76. Then your result will be 76 over 12 as an improper fraction. You can go ahead and do the same thing with this. 8 multiplied by 4 again will give you 32. 32 plus 2 is 34 over 8. This also is an improper fraction. You can go ahead and do it this way. But I mean, like, the numbers are big. Maybe some of you are not good at multiplication. If you have calculators with you, no problem. You can go ahead and do that. You can go ahead and use this method. Then from here, you use the very method we were using before. Split this into something multiplied by 12, which is 12 multiplied by 6, or 6 multiplied by 12. You can go ahead and do the same with this, okay? But for the sake of this video, I'm going to use a simpler approach, okay? So that without a calculator, it's still fine. You can go ahead and solve it. Now, uh, here's the thing. We can simplify 4. Let me use a different color for that. 4 goes into itself is 1 times. 4 goes into 12 is 3 times, okay? So 2 goes into itself 1 times. 2 goes into 8 is 4 times, okay? So we have done our simplification. Let's do that down. We have now 6 plus 1 over 3 plus 4 plus 1 over 4. Well, now, if you want, you can go ahead directly from here. You can change this into improper fraction. Change this one also into improper fraction. Then use LCM, that's lowest common multiple, as I did in the previous examples, to find your answer. No problem. The method is correct. The answer will be correct, okay? Let's go ahead and do this. Or also, if you want, because this math, we have different methods of approaching. If you want, you can just isolate this 4 here, maybe add it to this to give you 10, so that you have the whole number on its own. Then you solve these two fractions together using LCM, lowest common multiple. Then you add the results together. They are both fine. All the methods are correct. And then they will also result into a correct answer. Okay? So you can use any approach that you are comfortable with. So I just want to show you here how to convert proper fractions into improper fractions. So that's why, for the sake of this video, okay, we just go ahead and then use the simpler method. As I said, I'm just going to say 6 plus 4, okay, this 4 here, then plus 1 over 3. I'm just rearranging them, okay. Now 6 plus 4 is just 10 plus. Now let's deal with the rational numbers here. 1 over 3 plus 1 over 4. Again, let's use LCM, lowest common multiple. The LCM of 3 and 4 is 12. We solved by this type of question before. It's 12, okay? So 3 into 12 is 4 times. 4 multiplied by 1 is 4. Again, just to remind you, you divide these two numbers, that gives you 4. Then you multiply this 4 by the numerator. 4 times 1 is 4, okay? In case you forgot. Again, 4 into 12 is 3 times. 3 multiplied by 1 is just 3. So we have the plus sign, then we have our 3 here, okay? Then from here, we have 10 plus. Well, 4 plus 3 is just 7 over 12. Now, this rule goes into place. Now, see, this is in the same format as this, okay? Now, well, I said, when you have a whole number like this, like a, then b over c, you can split this into a plus b over c. The same thing is true because this is equal sign. If this is equal to this, then this is also equal to this, okay? So in this time, we are going to convert this into this. So that's the case we have here. So this is the same as 10 whole number 7 over 12, okay? You just take this and then attach it to the fraction. So it will be a 10 whole number 7 over 12. That is a mixed fraction, okay? And I think by this is clear. Again, maybe for the sake of clarity, we can go ahead and solve one more question, okay? And then we end this lesson there. Let's say, and this one is not going to be a hard example, by the way. I just want to show you how to do LCM of maybe. Okay, let's just solve a simple example because I will make a video about rational fractions again that will go deeper into harder questions, and complex examination type questions. Maybe there I will go ahead and then solve those kind of difficult questions. But for now, for the sake of understanding, because this is just the basics, someone who is new, like just been introduced to fractions, okay? That's the purpose of this video. Now, when you have this kind of questions, what should we do? Well, some students will go ahead and say 4 cancels 4, 5 cancels 5, then the answer will be 8 minus 10, and this will give you minus 2. And exactly they are going to find in the options, in the multiple choice questions, they are going to find a minus 2 there, which is a trap. And they are going to circle that minus 2 and get the question wrong. Remember, it is here still now. That's why I left these two on the board, because they are very important. If the property in between the numbers is addition or subtraction, you cannot go ahead and cancel the numbers, please. And this is a very common mistake that students make, okay? If the operation is multiplication between them, there's no problem, you can cancel them. But other than that, you cannot cancel them, okay? So this is just a trap. But for those of you who are watching this video, because you are aware of this, so you will not fall into such traps, okay? So let's go ahead. We cannot cancel the terms. What we can do is to add these terms and then add this, okay? So 8 plus 4 is just 12 over 4, minus 10 plus 5 is just 15 over 5. Now it's time to split our numerators into some multiples. Well, what multiples do we use depending on the denominators, okay? So that we can have this form. Well, 4 multiplied by which number will give us 12? It's 3. So 3 multiplied by 4 is just 12, okay? Minus. Here also, the denominator is 5, so we consider 5, we said. 5 multiplied by which number is equal to 15? The answer is 3, okay? So 3 multiplied by 5 is the same as 15, so over 5. Now, you are free to use this property here. You can go ahead and cancel them. Why? Because the operation in between them is a multiplication property, okay? The property is a multiplication property in between them. So from here, you can go ahead and cancel 4 and 4, cancel 5 and 5. Then you are remaining with 3 minus 3, which is equal to 0. So this is the final answer to this question. Now, if you like this video, please consider subscribing to my affiliate channel, like and comment, and also share with your friends. That is the best way to support what we do. Thank you for watching this video again.